So hello everyone, welcome back to the new video. In this tutorial, we'll be discussing about data structure. Introduction to data structure, its characteristic, arrays. Okay, arrays, and also we'll be discussing about the arrays. Okay, so let's start from the introduction. So first question is there: what is data structure? A lot of people will tell you you have to discuss about the DSA. Okay, DSA stands for data structure and algorithm. That means the structure of data using algorithm. Basically, you structure your data with help of different data structures, and you apply a lot of algo over there, right? So basically, if you're not understanding anything, so let me start from the very beginner. Okay, so here is a data structure. Data structure means like structure of data. What does it mean, a structure of data? The structure of data means the organization, the storing of data, how our data is stored, how it is organized, in which manner it is organized, right? So let's discuss about the data structures. A way to store and organize data so it can be efficiently. It's not like that we used, we structured our data and what will happen is it's gonna decrease the speed. Efficiency is gonna decrease. No, this is not. Okay. We have to organize our data so that it can be used efficiently. Efficiency doesn't decrease anymore. Okay. Rather it increases. Okay. So we have array. You know what is array, right? Compound data structure. In the video of compound data structure, I have already explained this thing. Array, linked list, and queue, stack, heap. Okay, this is compound data structure. That means it is the combinations of data types, like integer, combination of integer, combination of data character, so like that. Okay, string is also compound data structure, right? So then we have stack. Stack is what? First in, last out. LIFO principle. Book of a stack. So basically, if you know, we'll be discussing about the stack later on video. Okay, we have another unit for this topic as well. Okay. So the question is, why data structure? Why data structure? Fast access. Suppose you in your home there are 10 people out there. Okay, everybody is living randomly, but what will happen? You you build a home, and in the home what will happen is you have a gallery, and both sides of the gallery you have just rooms in what? In linearly. Rooms are linearly arranged. Gallery, you have the both side you have linearly room arranged, and in the middle what will happen is you have a gallery. Okay, so whenever, and also you have written like room number 1, room number 2, room number 3, room number 4, room number 5. So whenever any random people will come at your home, you know that room number 4 have no people, this is empty room. Okay, rather room number 5 and 6 is filled. Okay, room number 1 3 2 1 2 3 is also filled, but room number 4 is not full. I mean, nobody is living in the room number 4, right? So the random people will random people will come at your home, and then you are thinking which room we have to give that particular people. Right, so that time what data structure stand out? Okay, you have organized your home rooms so that you have just written room number 1 2 3. So whenever anybody come, and then you don't need to waste your time to check out each rooms, right? Which room is filled and which room have any people or not, right? So you directly can say, okay, we'll stay you at room number 4 because we don't have any people in the room number 4, because everybody knows, right? Room number 4 is there. Everybody can say, okay, I live in the room number 1, I live in the room number 2, I live in the room number 3, same as 5 and 6 also, right? So this is why data structure. This is structure of people, structure of room over there. Same that is happened for the data as well. Our data is not structured in any manner, so we have to store it in a organized manner so that you know accessing can be fast. So here what will happen, you are not gonna waste your time to find out which room is empty, right? Rather you are just knowing like room number 4 have no people, in the room number 4 we don't have any people, and yeah we can say these people that okay you can stay in the room number 4. Okay, so this is what exactly happened when you organize something. Okay, so if you organize something, so accessibility can be become very easy peasy, right? Okay, so first thing was easy, I think. Efficient memory use. Memory use means, yes, memory use is also matter here. Let me give you an example for the efficient memory use for the, because suppose you have three things in your room. I mean, there is a room, you have a room, right? So in the room, what will happen? You have three things. The biggest thing might be fridge, cooler, and maybe table, study table. Okay, you have three things, and you didn't even arrange it. You just randomly put anything anywhere, right? So what will happen? It is not arranged, and whenever you know you have a lot of things, you you maybe bring some lot of things and you have to arrange it. No, you cannot do that because you doesn't have even structured the previous data. So it is not it is not using your memory efficiently. The storing the room, it is not using your room properly. The room is working as a memory over here. So you have to fix the things, you have to structure the data for what? The things that you have explained in your room, right? So once you go through this thing, you might be knowing about the efficient memory use. How you can use memory efficiently. Okay. Efficient memory is also used when you have to use your memory properly. That means you don't need to occupy any spaces. You have to fill all the data firstly, like first fill the box number 1, then 2, then 3, like that. You cannot skip the box number 2 empty, right? This is not efficient use of memory. Okay, so let's try to understand this third topic now. So in the third topic, what is written over here? Easy operations. Operations can be easy, right? So insert, delete, search, that's all three things I have already, explained you in the example number 1. The example for the rooms, right? Insert, like you can insert this person in the room number 4. Delete, you can I don't say, but deletion is what? Removing the data. So you can remove the person that particular room from room number 4. Okay, you can search it. You are aware from this that room number 1, 2, 3 have this particular person. Okay, in your, I mean, your family member, whatever you want, right? So in the room number 4, who will in the room number 4 will stay? So answer is, in the room number 4 will searching is kind of easy, right? You can search the data from this also. Whenever you have searched this particular people, the guest itself, you can say, okay, we have, whose room was empty? The room number 4, right? So searching is going to be easy also for that. Okay, let's talk about the characteristic of data structure. Characteristic is what? Characteristic is what? Why we have to use it? What will happen if we organize our data? What will happen? What the use case? What the what advantages? Kind of advantages you can say. Okay. Efficiency. Efficiency. It increases efficiency. Scalability. Flexibility. Simplicity. Reusability. Okay. Efficiency means fast operations. Operations means delete, insertion, and searching is gonna be easy. Okay. Scalability. Scalable. It becomes a scalable means it can handle large uh, uh, amount of data. Okay. Flexibility. It can adapt to needs. Simplicity. Implementation is gonna be easy, right? Reusability. Yeah, used in multiple programs. So this is what characteristic of data structure. Okay. So I think data structure is gonna be clear to you. The introduction firstly, okay, and then we'll move to the what is array? Array. Collection of same types of data, like for the int, char. Here is also array. Sometime you might be thinking that combination of array, combination of character can create a string. Can we say string is also compounded array? So yeah, answer is yeah. Yes. I mean, string is also kind of compounded array because you can create it with the combination of a lot of character. Okay. So after that, we'll be discussing about the key properties. This is super important topic. If I talk about it in the perspective of this topic, this is going to be different from this. So we have same data type, fixed size, index-based access is stored in contiguous memory. And then we'll be moving to 1D array representation. Okay. We have same data type, fixed size. Fixed size means in the array. Array are static. While we'll be also discussing about the vector. Vector are what? Vector are basically dynamic. Okay. So this is something that we have to know actually. Okay. We have to know 1D array representation, and then we have to know about 2D array representation, and then same that will happen for the multi-dimensional or 3D. Okay. Collection of elements of same type is stored in contiguous memory. This is called the array. Okay. And then we have key properties. One D representation. One-dimensional data representation. Basically, data that the array you can think it like matrices. Matrices what? Matrices, 1D, 2D matrices are there, right? So it is also 1D, 2D and multi-D. Multi-D means multi-dimensional array. We have multi-dimensional array also, we have 1D array, we have 2D array, right? So array is also sort of matrices. If you are knowing matrices, so you can relate it from this as well, okay? And then we will also discuss about the address. How will you find out the address of any, any particular element? So let's drop this topic as of now. What we'll be discussing is key properties, okay? What is a sparse matrices? Sparse, like the sparse array is a sparse matrix. That is definition we always similar. Like if you talk about this, matrices or array, sparse meaning most of the elements are gonna be zero. Okay. Same that is happened for the dense, but as the opposite of dense. In the dense matrix, dense array, what will happen is maximum elements, minimum element are gonna be zero, right? Also, you cannot say also you cannot say that this is a zero matrices, because in the zero matrices, what will happen is move all elements are gonna be zero, right? So a lot of people might be thinking that sparse matrices can be null matrix. So answer would be no, because in the null matrix we have all the elements are zero, but in the sparse what will happen is we don't have all elements are not zero, maximum elements are zero. Okay, so this is what I was telling. Okay, so dense, in the dense, I'll show you dense array, okay, because we'll be discussing about the array, so I don't I'll not discuss about the matrix over here. Dense dense array dense array, I'll show you dense array. So in the dense array, what will happen is the data structure where all the statement are contiguous memory featuring sequential indices from the zero. So also I'll show you one of the example. I'll show you. Okay, I'll click on the images, then I'll see the example, then I'll show you the example also. So I don't think it was dense. Yeah, here. It's a better example. You can see over there. So here in the example, you can see this. We have 2 space tiles, and then again we have 2 space tiles, right? This is dense. This is sparse. How will you configure? How will you categorize into the dense and sparse matrices? So in that dense matrices, almost all the elements are non-zero. Almost all the elements are zero. So this is what sparse and dense array are. Okay. So I think that's till now you have understood the topic. Okay, so let's back to our next topic. There was a rectangular matrices, triangular matrices, lower triangle, upper triangle we have. Okay, first I explain you this thing, tridiagonal matrices. Don't worry, I have already created a video for the matrices. What is matrix? How many times matrix? Not is it's not mathematical one, but how you can implement through using the array. This is what I have covered in the matrices lecture. Okay, so that might be very helpful for you all, everybody. Okay, so I'll upload this lecture by I think I'll upload the video by Yeah, on this week. Okay, on this week I'll upload it. Okay, don't worry. Okay. So I'll just explain you what is chi diagonal. Chi diagonal means chi means three, diagonal means diagonals. So we have a main diagonal that's called the principal diagonal. Okay. Tri diagonal matrices are two matrices. For that, upper diagonal, lower diagonal, and main diagonals are not non-zero. That means if we take an example, पानी 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 है ना कॉपीराइट आ जाए वीडियो का म्यूट कर दे तो बोले दोनों जने परेशान ऐसा करेगा स्विमिंग पूल में नहीं तुम्हारे मुंह में बैठे वीडियो बना रहे बोला ना शांत So in the tri-diagonal matrices, what will happen is we have three diagonal matrices that is non-zero. Okay. So in the example, you can see this, we have 3 cross 3 matrix. So that all the stuffs are applicable for the square matrices. This is the conclusion of this lecture. Okay. Everything is gonna based on just square matrix. Okay. So basically we have a main diagonal, okay, we have main diagonal, upper diagonal, lower diagonal, okay. So tridiagonal means we have a matrix that have three diagonal, like this diagonal 1 4 7 main diagonal and then upper and then this is upper and then lower diagonal. Except these three diagonals, we have all the entities are zero. This is non-zero, and except these, all the elements are gonna be zero. Then it would be called the tridiagonal matrix. Okay, we have a triangular. Triangular means we have a sort of triangle. Triangle means. Let me tell you what exactly this means. Triangular matrices means those matrices that create triangle. Triangle for what? For zero. So we have two types of triangular matrices. This is also this is applicable for the square matrices only. Okay. So basically we have lower diagonal matrices, we have upper triangular matrices. So I'm just telling you the trick over here. Lower triangular matrices are what? Triangular will create on the upper side. Upper side. That means here this if you create this from this is nothing, this is a triangle, right? You can rotate your you know phone, laptop, whatever it is, and then you can say this is from here you start and then go there, go here and then this will create a triangle, kind of triangle. Okay, so this is what triangular matrix is. Okay, and then we have upper triangular matrix. In the upper triangular matrix, what will happen is we have a triangle of zero. That is what? That will create a triangle. This is what exactly triangular matrix means. If you're not understanding this thing, let me give you other definitions also. So basically, lower triangular what means? We have all elements are zero above diagonal. This is main diagonal, right? 1 3 6 is principal or main diagonal. So above all the elements are gonna be zero. Above all the elements are gonna be zero, and that create a triangle. Okay. So this is principal diagonal, and above all the elements are gonna be this. In the lower we have above zero. Okay. And in the above we have below the elements are zero. Okay. I think you understand this thing very well, right? Triangular matrices and then we have tridiagonal. Okay. Vector representation. Vector representation of matrices are, yeah. Vector representation of matrices are gonna be easy peasy topic. Okay. How you can represent your matrices through vector representation. Instead of storing full matrices, store only useful values. So lower will store this elements, upper will store this elements. If you add this thing, this is the element actually. Yeah, understood. These are total elements. How many elements are there? How will you find out using this formula? N is what? N is what? N is basically its order. Like if it is square matrices of 2 cross 2, then it's the value of N would be the 2. 2 cross 2, 2. 3 cross 3, what it would be? 3. 4 cross 4, what it would be? 4. 5 cross 5, what it would be? 5 cross 5. Okay, so this is something that I was telling. Okay. Later on in our lecture, I was telling this. Okay. So avoid, please try to avoid the background noise because we have a lot of background noises right now. Okay. So, okay. Let's try to solve some sorts of MCQ, whatever we have seen in this lecture. Okay. After the MCQ, in the next video, we'll be discussing about code implementation of it. Okay. So array stored elements in contiguous memory. I've already explained this thing in the previous video. Okay, if you haven't yet watched the video, go and watch this video and then come this video. Okay. So array stored elements in contiguous memory, one after another. So whenever memory location, the memory, the address is gonna be contiguous. Okay, one after another. Sparse matrices means what? Sparse matrices, all the elements, mostly element are gonna be zero. Mostly zero elements, yeah. This is this one thing. And if I ask what is the dense matrices, can you tell me? Can you tell me? Huh? Can you tell? Okay, nobody can tell. Okay, I'll tell you what is that is. Mostly element are non-zero. That is super simple. Sparse is reverse of dense or dense is the reverse of sparse, okay? Element below diagonal or what called? Below, here below is used. Reverse of below, what does it call? Upper. So what it would be? Upper diagonal matrices. Okay. So I think that would be the helpful for you everybody, okay? And then storage for tridiagonal. Yeah, this thing. Whenever you see tridiagonal means what? Tridiagonal. Tri means three, diagonal means diagonal. Diagonal means what? Whenever we discuss about the diagonal, we usually consider it as a main or principal diagonal, but here we did. I mean, it would be mentioned for sure that main diagonal, there is principal diagonal, main diagonal. Okay. So since here no diagonal is mentioned, so we'll be taking all the three diagonal, upper, lower, and main principal diagonal. We always use principal diagonal as a diagonal. Okay. For what? Rows and columns are gonna be 0, 0. For A11, A22, A33, A44, A55, we have 5 cross 5 matrix. Okay. Okay, I think that would be the helpful everyone. Okay. So let me give answer. So basically first B, always B, and then for B, okay. Question number third, what we have? Upper B, okay. Below upper, okay. Question number 4, we have C, okay. And yeah, we have only 4 questions to go in. So let's try to solve some sorts of MCQs also. Give me 100 MCQs and I'll I'll give you the answer. Okay. So let's try to write down answer from this. Area would be, I think, C. Stack B. Okay. Which TS is used? Okay. Stack Q. Mostly 0. Lower diagonal means above diagonal are 0. Okay. Above. Upper diagonal vertices B. Triangle matrices store what? 3 diagonals. All elements, only diagonal, 3 diagonals. 3 diagonal, non-zero, 3 diagonals. Okay. Space, lower is also similar to the upper one. So upper is this, lower is also this. Okay. And then question number 3, space for tri diagonal for what? Option C. Okay. Time complexity of linear search. Linear search. Option C. I think not. I'm not sure actually. Binary search works on what? Always sorted data. Okay. Complexity of binary search. Array size is fixed. Didn't I mention it earlier? Yeah, I did. Which is not linear DES. Linear means tree, non-linear data structure. D would be the final answer. Traversal means traverse to visit all the elements. Okay. Best case would be the A option. Worst would be, I think, option D. Area index start from 0. Push pop. Yeah, push pop. 20 questions. Okay, let's see how many questions we have given correct. Okay, 4. Oh my god. Oh my god. Oh my god. So our okay, let's see. I have given 5 bad. I have given 5 wrong answers, so how it would be 14 by 15? Okay. Area are not dynamic. I think I have written 14. You marked A, I didn't mark A. 14, I think. 14, let me try. I didn't recheck. Cross check, okay. 13. Let me write down the answer firstly. Binary search complexity. Omega log. Yeah, actually I did wrong. Accuracy is 85%. Okay. Next questions. Please ask for the whole complexity and for searching, sorting, array, stack, cube, whatever. Best case of the bubble sort. Best case would be D. I don't know. Let's give it a try. Let's take option C. Option A. No, no, no. Option A. Array would be option B. Option C. Option A, I think. B. B. C. B. B. C. No, A would be the correct answer, I think. Oh my God, so many bad answers. I actually don't know about it, so that's why I'm making a lot of mistakes. I think we have only 4 questions correct. Time, misplaced, complexity, full clarity. What is the How the running time grows as input size increases. Yeah, I know. As you increase the input size, it will increase it. Okay. First we have omega 1, that is constant time complexity. And then we have omega log n. Then we have n log n square, n cube, factorial. And then after we have also factorial as well. Okay. Direct axis. Okay, constant. Okay. Single loop, omega n. Double loop, nested loop, omega n square. Halving. What is halving? When is such pattern? It is a fundamental technique used to reduce the size of a problem by 50% of each step, usually dividing the. Okay. Decrease the size actually. Okay. So it uses to decrease the size. Okay. So its time complexity would be the omega log n. And then we have this. This is a merge sort, right? Quick sort and merge sort at best. Constant time complexity. Okay, yeah, it is also for the direct axis, right? Constant axis. Point 4. Point 50. 50. 1 by 1. Is that like middle? Is that with 25 at index 2? is also omega. Whenever we check elements one by one, then it would be omega n. Okay. Shifting and deleting elements. Shift elements omega n. Space complexity. Store an elements. Like see it in a row, fixed position. That is what corollary, right? A stack, we have stack heap. Okay, the stack will be discussing this. You are just pushing an element, right? Either on the stack, yeah, stack all operations will perform on the top stack, right? So it will be the same for the push and pop. Okay, element inserting, deleting, and also it would be. But yeah, one thing that I also think is for traversing it will be omega n because you are reaching one element and then again after one another, right? So it will be omega n traversing. To display, I think I'm not sure whether for the display what would display. NQDQ. NQDQ is also same to the push and pop, right? Saying that it happened for the Q as it was for the stack. Okay. And then we have searching, so it would be omega n, right? But why is omega 1? Why time? I mean, why this constant number? There is no change now. So why it is like that? I mean, ठंडी ने गिरा ढीला लैपटॉप को गरम गरम थोड़ा लो ठंडा कर पानी ने गिरा नीला अनम्यूट करते ही we are sorting also. Okay, we have sorting. So it would be omega n square, I think. Because nesting, for the nesting we have square. Key comparison table. Let's try to understand from this table also, okay? We have B, we have again B, we have A, we have C, I think. I didn't cheat it, so let's see whether which one is correct and which one is wrong. Okay, so my third is wrong. That was what? Boundary search. Boundary search. Okay, I correct. Oh, okay, I checked A. A is the answer, I think. Also is POQ. So let's try to understand from the table. Okay, we have the table also here. Click on F11. No, no, no. Function F11, I think. It's already, I think, full screen. F1. F1 is for help. No, no. F1 is for mute and mute. Okay, understood. So we have key comparison table over here. So I don't prefer to learn it manually. Rather first understand and then try to resolve it by yourself. And once you get stuck anywhere, then you can refer this table. Okay, this is what I think. What I think would be the better option to learn anything, firstly. And let's complete and try to paste it. I want to see in which format it will paste. Control V. Oh my god. I didn't expect that it'll print, that it'll pasted like that. Here in the table, I can see this is their time complexity and then how, I mean, the growth rate that is something. Okay. So yeah, that's all in this video. We'll be continuing this lecture for the other videos, for the upcoming videos. Okay, so yeah.